write out some stuff first. So when I make from yesterday, my equation for confidence interval starts with what? My equation for confidence interval. My point estimate. Y'all don't have to write this anywhere. And then what? Well, in between that, plus minus my z star times. Alright, so this is called point estimate. This is called what?
Critical value.
This right now is just standard deviation. And this whole thing is called what? So the first thing that's on our list is margin of error gets smaller when. So things in here have to change to make that smaller. So what are things that could change there to make that green part smaller? How do I change this? What do I get this from? What?
Area.
What does the problem give me to find z?
Confidence.
So if my confidence level, would need to do what to make my margin of error smaller? Which in turn makes my critical value lower. So if I want my margin of error to be smaller, so like if I am presenting data or results or something, I don't want to be like, oh yeah, I'm pretty sure that the scores on this test are going to be between a 10 and 100. Like that's not very helpful. So we want to make our margin of error smaller, obviously. What's another thing that I can change?
A bigger population.
Bigger
sample
from the population. So this is the one that is one that, like, if you're actually doing a study or an experiment, that's one that would be the most useful and the easiest to deal with. So I would do what to my sample size? Increase. So increasing my sample size basically makes it better, which makes sense that if I have more data, my results are more reliable. This last one, I don't like putting it here because it's not something you can change. But what's the only thing in margin of error that I haven't talked about yet? So my standard deviation, if my standard deviation did what, my margin of error would get smaller. Yeah, decrease. This is something I can change. This is something I can change. This is not something I can change. That's why I said I don't like mentioning it. I don't want you to think that's something I can do. And it should make sense here. You shouldn't have to sit there and think, okay, I need to memorize which one gets smaller, which one gets bigger, when. This is just algebra. So in this margin of error equation, the change in these directly are the exact same as margin of error. Like if my z goes up, my margin of error goes up. My standard deviation goes up, my margin of error goes up. But this one is opposite. Why? Because it's dividing in the denominator, so it's opposite. That should not be that hard to think of. I always have people who try to memorize that, but that's not something you should need to memorize. Alright, so we're going back to this same equation. So our margin of error, and this part you might want to write kind of small, is equal to, what did we just say? What's the first part where margin of error starts? Times Alright, so we've actually dealt with something very similar to this already. in chapter 7, but we talked about if I change my sample size, what's going to happen to my spread. Well, your margin of error is your spread. So instead, we're saying we want a specific margin of error. How big of a sample do we need to do that? So we're solving for n. It's finding a sample size. So algebra here. If I want n by itself, what's the first thing I could do over here? I want n by itself. What's my first thing mathematically to do? Multiply both sides by square root n. What's my next step? So right now I have square root of n is equal to z times sigma divided by margin of error. My last step is what?
Square. You keep this star right as z.
And so this is saying my minimum sample size, so I need at least this many to make sure that I get my margin of error that small. So even though we were using the equation of what margin of error is equal to, my n has to be at least as big as whatever I find. So you can do this if you are really doing a study and you're like, I'm doing a political poll and I want to make sure that my answer is correct within 3%. I can do this to figure out how many people I would need to interview in order to get that before I ever started my sample. All right, so heights of Jamin, male students, normally distributed. Why is normally distributed important? What in that equation cares that it's normally distributed? Z. If that gives me my sigma, what is this problem actually asking me to do? What is the question actually asking? Right, so that tells you, oh, I'm not doing a confidence interval. It's asking me to find the n. That is a very different problem.
You did that because it's that sample.
How large the sample, yeah. All right, so when I was going over the homework, I said this within is a key word a lot of times for the what of the problem? Your margin of error. So this is your margin of error. Because you want to be within this way or this way. And then we've got a 95%. So because we've got the equation directly in front of us, let's not go through the whole algebra again. Let's just start where we know the equation ends up. I would not suggest memorizing this equation because it's just algebra to flip it over, but some people will, and that's fine. Our lowercase n is greater than or equal to our z star times sigma over margin of error, and that whole side is squared. So I'm plugging in my numbers. Does anybody remember what our z star was for a 95% confidence interval? We only did it once in this class. 1.96. What is our sigma? 2.5. If you need a calculator and you haven't gotten one yet, go grab them on writing this. And then so my within is literally how long do you want that blue line to be, so you just write it as exactly as it gives us. So this is 0.75. The actual answer you get is what?
6.5.
You didn't square it.
42.668.
0.6 what?
8.
And 4 people. Alright, so these are usually talking about something I have to sample. Is 42 enough? So how should I really write this answer? I need at least 43.
How do I know we need at least?
And I could write male jailman students. This is always going to be greater than or equal to. So I always have to go up to the next whole number. Because 42 is not enough. 42 is not at least 40 that much. Does that make sense?
How did you know the 95% confidence was 1.96?
We did it once yesterday. I should have gone through the whole process that did this again and then wrote 95 and then did this is 0.025 and then look it up. But there's a reason I'm not making you do it right now. Yeah.
For problems like that, we would expect the 95% in the graph and everything. Okay.
In 5 or 15 minutes, depending on which one I start to do, I'm gonna show you why I'm avoiding this so much. Like it's gonna be so much quicker for you in a second. Questions on this one? Alright, now this one, I rearranged stuff and then I realized that it's about order. There's not a standard deviation given in this one, but it's the same context as number 3. So the standard deviation with number 3 was what?
40 times.
And just because I've moved stuff around so much, let's switch this and make it 90%, because I don't want both of our examples to be 95, because I don't want you to think you always do 1.96. Alright, and I want you to do that problem real quick.
Yeah, I don't know how to find the Z for 90.
I'll go over it again.
Yeah.
Yeah, but close, there's 2 different
Alright, I'm gonna do Z star up here, but I wouldn't waste the time to write it on your paper, because like I said, it won't take very long to just start memorizing these. Where do I draw 90%? In the middle. So what do I now do with 90%? 100 minus 90%, which gives me 10%, but that's both tails together. So I do what with that? Divide it by 2. So this tail is 5%, which we typically write as. So now what do I do with 0.0500? Find it on the yellow sheet in the middle. What's my weird thing about 90? It's exactly between 2. It's not closer to either one. So we write this one as, this is the one that we actually write as 3 decimals because it is directly in between those 2.
So in our equation, are we talking that in the positive value of it or the negative value of it?
That's why I do star is positive because you have positive, negative,
So which one do we use in the equation?
positive. And so when we type it in, what's the actual number we get here?
190.
190 point what?
9%.
So, and I don't care if you ever write this one or not. I'm just showing you that this is what you should have gotten and this is the answer. So our actual answer is so anytime it asks for how large a sample or how many do you need, this is the process that you actually go through. Questions? Go ahead and plug those numbers in a list in your calculator.